Okay, so good morning, everybody. Today I'm telling you some things about neutrinos. Yeah. I also prefer to talk to you about sitcoms and Sheldon and Barney and all that stuff, but what? So I was thinking how to make this presentation at least a little interesting or a little entertaining, and I was thinking very hard for a very long time, and in the end I reached the conclusion that that's impossible. So I just decided to to try to make it a simple presentation, okay, so you won't fall asleep. Okay, so make yourself comfortable, and if you want, you can play with your computer while I'm talking. So the first big question is, what is a neutrino? Is that something to eat, or nah. It sounds kind of radioactive, doesn't it? Okay, so this is science. So you know that we're all made of atoms, right? Okay, so you know that an atom consists of a nucleus, where we found protons and neutrons, and constantly spinning around the nucleus, okay, we have the electrons. Well, the electrons, sorry. So this is the smallest form of materia, that exists, right? You know that, right?
Yeah.
Yes?
Yeah.
Well, you don't, because it isn't. Actually, if you have a look, for example, a proton is made up of 3 quarks. So you can say that a proton is made up of smaller particles, okay? But quarks aren't. Quarks are elemental particles. We call it elemental particles. So that means that they aren't made up of smaller things, of smaller types of matter. Okay? The same happens with neutrons. So what's the difference between a proton and a neutron is the combination of quarks. Okay, so you can see that this is 2 of the same type and 1 different, and this is a different combination. Okay, so but I think the reason why we never talk about quarks in particular is because they always appear in groups. Okay, so they always appear in groups of 2 or 3, forming bigger particles. So that's why we always talk only about protons and neutrons. So let me see if you can think logically, okay? A proton is made up of quarks. A neutron is made up of quarks. So electrons are made up of? Quarks? No. You have to listen better. So, okay, please have a look at this, okay? This is, you know this one, at least I hope so. This is a periodic table of the elements. We use this one in chemistry, and it's a collection of all the elements that we have discovered so far, all the chemical elements that we have discovered so far. And now have a look at this one. This is called the Standard Model of Particles, and it's kind of a periodic table for physicists, okay, in physics. So this is a collection of all the elemental particles that have been detected in experiments up to this day. As I just told you, we have the quarks, okay, this group, these 6 are the quarks, which form protons and neutrons. Here you can find the electron. And down here, these 3 are the neutrinos. Mind-blowing, it isn't? Yeah, so I'm sure now you feel like 5 times more intelligent than before. So, okay, now you know more or less what a neutrino is. It's an elemental particle. So that means it's one of the particles that can be divided into even smaller ones. So what is so special about them? Basically, it's very simple. There are many of them. For every proton, neutron, and electron in our universe, there are about 1 million neutrinos. And the funny thing, or the other ironic thing about this, is that they practically don't interact with matter. So, right now, every second, approximately 650 billion, yeah, I can pronounce the number, 650 billion neutrinos coming from the sun are penetrating every square centimeter of your body. And you're ignoring them, 1 neutrino. So, in other words, they are a lot.
You're worrying about Wi-Fi.
Well, they are harmless. So. At least we should probably. So if they don't do anything, what are they good for? Precisely because they don't interact with matter, and now it's getting a little bit complicated. Um, since they don't practically interact with matter, they conserve a lot of information about their origins. So, for example, when a star explodes, we also call this a supernova, okay, this is a star explosion in another galaxy. The explosion sends off a huge amount of neutrinos. So, if we can detect these neutrinos, we can determine, for example, the energy of the explosion, or also almost the exact direction of the explosion, so we can know where the explosion takes place. Another thing that's very interesting, I think, about neutrinos is that the neutrinos that come from a star explosion arrive at the Earth earlier before the light of the explosion. Well, usually we say that the speed of light is the maximum of speed, and that's true. The speed of the neutrinos isn't actually higher than the speed of light. The thing is, the supernova is at a very long distance to the Earth, okay? And since it's a ridiculously long distance, there's a lot of matter between. So the light particles interact more with that matter than the neutrinos. So you could say the light particles are slowed down by the matter, okay? You could say the matter acts like a brake, okay? So it slows down the light particles. And that's the reason why the neutrinos arrive before the light. So if you detect the neutrinos coming from an explosion, it's before you can see the light with the telescope. And this will be useful to give an announcement, for example, that we know that that an explosion is taking place, to study it better, to be prepared for that. Actually, around 2 years ago, there was about 2 years ago there was a big debate about this thing with the neutrinos moving faster than light, because some scientists measured neutrinos that were moving at a higher speed than the speed of light in a vacuum, which is the absolute maximum, okay? And, well, saying that neutrinos can move faster than light in a vacuum means to crash all his theories, okay? All the theories of Einstein and the theories of relativity. And crashing his theories means to punch modern physics in the face, basically. So, I think it's rather good, in my opinion, that it turned out in the end that this was just an error in the measurement. Well, saying that his theories are wrong would be like telling you now, after all these years studying, that 2 and 2 don't make 4 but 5, you know? You would commit suicide immediately, so okay, I'm already about to finish. I just wanted to point out some curiosities. Well, you know Sheldon from the Big Bang Theory? Yeah. He works with these things, so if at some episode of the show he talks about neutrinos, think about me, I told you. And for the people who think that particle physics and all this stuff isn't actually important for our daily life, the computers you're using right now, and all your mobile phones, and your iPad, were all partially developed thanks to particle physics. Okay? So I just wanted to point it out. So neutrinos and Candy Crush aren't that much separated. Okay, do we have some time? Because I was thinking about showing you a video.
We have 5 minutes.
Okay.
Is that okay?
Yeah. Well, this is the end of my presentation. I'm just going to show you a little video, which is no more explanation. It's just something that I found very curious. It has nothing to do with neutrinos. It's just an impressive video about an experiment with quantum physics, okay? Can I use the... I have to look for it on YouTube.
Whatever you like. This is yours now. Since we need neutrinos to use it anyway. Have you finished?
Yeah, now you can tweet it.
And they are actually evaluating you from what I see. Weird. I hope YouTube is not gone.
Don't ask me how that works. I don't know, but cool.
Levitation. Oh my god. No hypnosis here.
So you see, this is a special kind of a magnet, which is a superconductor. And you can see that you can lock in the magnets into different positions. So it doesn't work like a normal magnet where you just repel or attract, but you can put it into any position.
Is that a frozen stuff or something?
Yeah, it's cooled down with liquid nitrogen.
Nitrogen.
Okay, you can spin it around, anything you like to do.
Oh yeah. I can see some.
Then what they did is to build a rail, to build like kind of a track.
Wow.
Oh,
And you can play around a lot with that stuff.
you bet.
And in the end, what they do, well, now it's actually, it flips the tail around.
Of course. Oh god. That's really cool. So this is what you will be doing in the future? Something as funny as this?
I hope it will be as fun as that. So this was my presentation.
Thank you,
Like-
Christian.